A 100 megawatt power generating plant has an efficiency of 40%. If water is used to carry off the wasted heat and the temperature of the water is not to increase by more than 12 C degree, what mass of water must flow through the plant per second? The 100 megawatt of the power is the power generated by the plant. So the output work is equal to 1.0 times 10 to the power of 8 joule in 1 second. The efficiencies of the power plant is given as 40%. So eta, that denotes the efficiency, is equal to 0.40. The wasted heat is the QC. We need to know what is the QC in order to find out what is the mass of the water that can be used to carry off the wasted heat. To find out the QC, we start by using the formula for the efficiencies, which is equal to the output work divided by the QH. Because we know what is the efficiency, we know what is the output work, therefore we can find the QH. To find the QH, now we change the QH as a subject to get output work divided by the eta. We substitute these two values at these steps to get the QH as a 2.5 times 10 to the power of 8 joule. This is the heat absorbed by the working substance in the power plant. We already have the QH value and the output value, output work. Now we can find out what is the QC, the wasted heat, which is equal to QH minus the output work. We substitute the QH value, 2.5 times 10 to the power of 8, and the value for the output work, which is 1.0 times 10 to the power of 8. Then we obtain the QC as 1.5 times 10 to the power of 8 joule. This is the heat wasted in every second. This wasted heat will be carried off by the water to the cold reservoir, and it will cause the water's temperature to increase. So that means this wasted heat, when it is carried off by the water, it is absorbed by the water. Therefore, we can set these equations where the QC equal to mc delta T, where the m is the mass of the water, C is a specific heat capacity, small c, specific heat capacity of the water, and delta T is the change of the temperature. But the temperatures of the heat now is limited. The temperature of the change of the water is limited by 12 C degree. The temperature of the water will increase, but is limited by the 12 C degree. So we want to find out how much water M is required to carry off these quantities of the wasted heat in every second. So we change this M as a subject. We will get the QC over C delta T. The QC take this value of this wasted heat, 1.5 times 10 to the power of 8. C is the specific heat capacity of water, 4186 joule per kg per Kelvin, and the delta T is 12 C degree. Therefore, we will get the mass of the water that require to carry off the wasted heat in every second. It is equal to 3.0 times 10 to the power of 3 kg. That means it is 3000 kg in every second.